Hello everyone, welcome to Build 2023. I am Sagar Lankala and I'm a Senior Product Manager in Microsoft Developer Division.
And I'm Jared Rewerts, Senior Software Engineer.
It's a pleasure meeting you all in person here, and a special hi to everyone who is joining us digitally. I'm super excited to talk to you about the work that we have been doing with Azure deployment environments and to empower developers and maximize their productivity. As Satya and Amanda mentioned in their keynotes earlier today, we work on ensuring that you and your teams are able to focus on writing the code that only you can write, make it more fun, and take the drudgery out. Today, we'll first talk about a new paradigm that we see in the cloud-based app infrastructure, and then we'll progress on to how we are empowering you to make that shift by providing a powerful but yet satisfying developer experience, while at the same time maximizing security, governance, and cost efficiency in cloud infrastructure. First, let's talk about this new paradigm in app infrastructure. In the last decade, DevOps has fundamentally changed the way we develop software, ushering in the new era of modern applications driven by transformative levels of efficiency and collaboration. While many aspects of the software development lifecycle has already been transformed by DevOps, software development infrastructure remains an inhibitor to efficiency and agility for developers. Plus, with the rapid evolution in the cloud and hybrid work, more complexity got introduced into the dev infrastructure provisioning, and that is causing challenges for developers and admins alike. Let's first take a look at the challenges that the developers face today. With the increase in the complexity of the applications, devs want to focus on their code and not spend hours configuring the infrastructure on which their applications are running. Devs are also not subject matter experts in configuring the infrastructure. They would like to do what they love, that is write code and build innovations and deliver it to their end users. This is forcing enterprises to lock down the subscriptions, resource groups, and so on, so that there is a lack of self-service deployment for the developers. This is also leading to long wait times, where the developers will have to wait for several days, if not weeks, to get a working environment for them. On the other hand, the admins have a different set of challenges. There's an increased risk of exposure, and any security loophole or vulnerability in the infrastructure can be exploited by hackers, and that will pose a security exposure for the entire organization. These are mundane, repetitive work that the admins are doing on a daily basis, and that is not something that they love as well. Finally, admins would like to ensure that there is cost efficiency in place whenever a cloud-based infrastructure is being used. So this is also very challenging for the admins. So in short, during our several customer conversations, what we identify is enterprises especially, are looking to strike the right balance between speed, governance, and usability. When we talk about speed, it is the velocity at which a developer is writing their code and delivering the innovations to their end users. When we talk about governance, it is having the right controls in place, ensuring that the right policies are enforced in the right environments. And finally, when we talk about usability, it is about the experience the developers are having when they are using and creating this cloud-based infrastructure. Enterprises are struggling to strike the right balance, and more often than not, governance gets the more onus, and that is slowing the developers down and also leading to a lot of dissatisfied developers. To overcome these challenges, a new approach to software development is required, and software development infrastructure is required, one that helps scale the capabilities of platform engineering teams to quickly and efficiently serve all the developers in their organization. Platform engineering is that new approach that improves developer experience and productivity by providing self-service capabilities with automated infrastructure operations. And we at Microsoft have been hard at work delivering just the service for that. Last year at Build, we introduced Azure Deployment Environments, a new service that empowers developers to self-serve app infrastructure using standardized project-based templates, and while at the same time maximizing security, compliance, and cost efficiency. Since last Build, we have worked closely with over 30 enterprise customers, spanning across industries like financial services, automotive, and more. Thanks to their invaluable feedback, we have added several valuable capabilities that help enterprise developers maximize their productivity. And today, I'm super thrilled to announce that the service is generally available. Any customer with an Azure subscription will be able to get started with the service for free. There are no additional costs to use the service apart from the resources that are created as part of the environment. We are also making another exciting announcement today that we will be supporting Terraform infrastructure as code within Azure deployment environments. This has been a popular demand throughout our preview, and starting today, customers will be able to sign up to access Terraform early preview, and over the next few weeks, we'll be onboarding them to the early access of the service. In the last few minutes, we talked about the challenges the devs and the admins face, how platform engineering is revolutionizing the way enterprises solve these problems, and how you can leverage Azure deployment environments, a turnkey solution that you can readily use, adapt to platform engineering, and take the really next step in DevOps. Now let's dive deep and see how Azure deployment environments is empowering developers to do their best work, help focus on the code that they love to write, and stay in their flow. With Azure deployment environments, a developer will be able to self-serve quickly and easily application infrastructure that is required to deploy their applications. This helps them identify and fix issues sooner and ship high-quality innovations to their end users. Developers will be able to achieve that by using infrastructure as code templates that have been provided by their dev teams or admins, and such as Terraform or ARM. Developers will be able to achieve that by providing some basic information that they're already aware of. And they'll be able to deploy this infrastructure directly from where they live, that is a customized dev portal or their favorite dev tools. A developer will be able to create and manage these environments manually on demand using the developer portal or their dev tools or the CLI. This will help them get a personal test environment where they'll be able to test new features, or a sandbox environment where they will be able to perform some experimentation. Or enterprises will be able to use Azure deployment environments and deeply integrate with developers' GitOps flows, so that environments can be automatically created when the developer actually needs them and delete them automatically when they're done using them. Let's show you a bit about what we are talking about here. Jared is a developer, and let's consider that he's joining the .NET Podcast environment, the project team, and he is tasked to build a new exciting feature called live streaming. Over to Jared.
Thanks, Sagar. So like Sagar said, I'm a new hire. I've been tasked with adding features and fixing bugs on the .NET Podcast application. So for me, my priority right now is just understanding this application, wrapping my mind around how it's built, and that way I can onboard to the product quickly and start implementing features. So if we take a look at the architecture, like a lot of modern web applications, the .NET Podcast relies on a lot of Azure services to actually deploy. So just at a cursory glance, we have 5 services. Some of those services actually support bidirectional data flow. We have 2 databases. We have storage accounts, key vaults. We have some telemetry lined up, and the container registry that we're pushing our images to. In addition to that, we have multiple clients that are connecting to the APIs. So for a new hire, it's just a lot to absorb. My initial impression is there's a lot of moving pieces. And really what I want to do is I want an environment that I can interact with, that I can break if I need to, and not be worried about impacting fellow devs on my team or our customers. So with that, let's talk about how deployment environments can actually help out. So Sagar mentioned this earlier, but deployment environments can be configured in a variety of ways. What I'd like to do is show a quick demo of how the developer portal can help me onboard as a new engineer. So if we look here, this is our developer portal. This is a custom portal that our developers can go to. They can interact with it. They can create their own environments and basically serve themselves. So you can see in here, we actually share this portal with DevBox. So really, as a developer, I'm coming in here, I'm writing my code on my DevBox, and I'm deploying that code to my environments. So I'd like to show how easy it is to create an environment here. So with a couple small pieces of information, I'm going to deploy this in the podcast app. We'll use the dev environment type. And next up, we have our templates. So Sagar referenced this earlier, but basically, these have been inner sourced within our organization. You can think of these as infrastructure as code, whether they're backed by ARM, Bicep, or Terraform. The point of these is, if we deploy it, it's going to stand up a bunch of infrastructure. So ultimately, our application is going to run on this. And yeah, these have kind of been within our organization. This represents the best practice for each of these. So the best practice for our container registry, load testing, or in this case, our best practice for podcast app. So this one does not actually take any parameters. It is possible to configure your templates to take parameters in. In this case, we don't actually require that. So we'll kick off a creation for that environment. What I'd like to do while we're waiting for that is pop over to one of our other environments here. We've got a few. And what I'd like to do is take a look at some of the resources. So you may recall from the slide we showed before, the podcast architecture, all the pieces in Azure. You can see a lot of them are in here. So ultimately, for me, despite the complexity of this application, I've just been able to create something that I'm going to be able to interact with. I'm going to be able to write some code locally and push it to this environment. And I don't have to worry about bringing down our dev environment or impacting our real customers. So with that, let's go back to the slides briefly. I'd like to talk about another way deployment environments can help me with my feature work. OK, so I just talked about the dev portal. I created my own environment. I'm going to be able to interact with that and break it if I need to. What we can also do is configure our deployment environments to be deployed in line with our GitOps flow. So basically, what I'd like to show is our GitHub repo, how it interacts with deployment environments, and how this can actually expedite writing features as well as actually reviewing code. So if we switch back to our demo screen here, what I'd like to show is our application. So this here is the .NET Podcast app. So this is what our customers use. They want to use this product to stream the latest and greatest .NET podcasts. As a new hire, my first feature work that I've gotten assigned is I've got to add the ability to live stream podcasts. So it currently supports streaming podcasts, but I want to support live streaming podcasts. So what I'll do here is I'll sign into my DevBox. So I've got VS Code here, and I've made a couple changes. So what I'd like to do is I've added an API for surfacing which shows actually support live streaming. I've made a couple of other changes as well. And I've surfaced our API changes in our front end. So the page we were just looking at, live streaming is going to be surfaced right there. So let's take a look here. Create a branch locally. And commit. OK, so when we push this to our GitHub repo, we're going to kick off a couple actions. So let's take a look at that. So we can see that GitHub's aware we just pushed that branch from our DevBox. Let's take a look in our actions view. Now, we've kicked off, based upon the branch that I just pushed to our repo, we are going to create a deployment environment that I can interact with. So this is very production-like. I'm going to get to interact with it. I can continue to push changes. It'll update the environment. And again, it doesn't impact the rest of the devs on my team, and it doesn't impact our customers. So this is really going to help me get the confidence I need to actually submit a pull request. So this takes a little bit. So let's take a look at a branch that I pushed last night. So similarly, that action we just saw, this is what it looks like when it completes. So we pull in a few pieces of information. We have a link out to the Azure resources. I'd kind of shown that before in the dev portal. You can access the actual infrastructure if you want. We have a link dynamically generated for our own instance of the application with our changes. And we actually have a link for our Swagger site, which I'm going to talk a little more about later. First, let's take a look at that site. So you can see I've surfaced the live streaming feature in our client. Customers will be able to use this, interact with it, and actually stream podcasts if they want. So next up, I'm feeling like it's time to actually submit the pull request for review. So let's submit our pull request. Now, just like when I pushed my branch to the repo for the first time, this is actually going to spin up an environment for our PR reviewers and assign all the engineers that are in the pull request group to that environment. So they can go in there, they can interact with it, and they can test my changes. So let's pop over to a pull request that I submitted last night and take a look at what happens when that environment completes deployment. So you can see here, we get a comment from a bot that has the same information we saw in the action. And in fact, there is actually an action as well when this is kicked off, so you can find the same information there. But in this case, we have the same information. We have our own pull request environment for our PR reviewers. And one interesting thing I wanted to point out here. So I showed the site before with my changes. We can also check out our Swagger site. So I did make a change to the API. So from the perspective of a pull request reviewer, this is going to really make it a lot easier to digest what my changes are. They can come to this site. They can interact with any of the API changes that I've made. They can actually see the response and see if it actually looks like expected data. And again, this is a totally separate environment from all the other environments. It's separate from the environment I created on my branch, and it's separate from the production environment. OK, so I've been given approval by my team to actually merge the PR. I resolved the comments. Let's see what happens when we merge our pull request. And let's clean up that branch as well. So now we can see, I mean, we've got a lot of environments floating around with a configuration like this, right? We've got all the feature branches. Every one of them has a dev's environment specific to them. Every pull request results in another environment for the PR reviewers. That's a lot of environments. So really what's going on is these are short-lived environments, right? You submit your pull request, and you tear it down as soon as it's been reviewed. And you can see we've already kicked off 2 jobs to delete the branch environment and that pull request environment. And so this is one of the ways we can stay on top of costs, but still really accelerate development. In addition, you can also see I merged into main. So we actually have this gated on approvals from some other engineers on my team. But the idea is you merge it into main. And the production website is also its own environment. So that'll go out and update the production website. So with that, that's kind of the overview of our 2 key developer tool integrations. So I'm going to pass it back to Sagar, and he's going to talk a little more about our admin site.
Thank you, Jared. Before you proceed, a little housekeeping for our in-person audience. If you have any questions, please scan through that QR code, and you'll be able to submit the questions directly. We'll try to answer a few questions towards the end, or some of our colleagues are online, and they'll be answering the questions for you. So Jared showed us how Azure Deployment Environments empowers developers to create environments on demand or through the automated operations directly. This really helps improve his day-to-day life as a developer and enables to focus on the more creative aspects of software application development. In the first demo, we saw that a developer was able to create an on-demand environment directly from a customized developer portal, and they'll be able, as you could see, they were able to quickly and easily create that environment, and they also have the ability to delete an environment or redeploy an environment if they would like to make changes to that environment. We're also working on adding an auto expiry functionality, which will help the developer to define an auto expiry, and that will automatically delete the environment based on the configured date. In the second demo, we saw an automated operation where there was a streamlined deployment of environments that was happening when the developer or the pull request reviewers actually need a working environment that helps them analyze the code, identify, and fix issues. So ADA helps enterprises revolutionize the developer workflows here, keeping the developers in their flow and identify, fix issues sooner, and ship high-quality innovations to your end users, and maximize their productivity and satisfaction as well. Now let's move on to how Azure deployment environments also greatly benefit the platform engineering teams here, eliminating redundant work that they are currently doing, giving them the ability to configure built-in governance and centralize control over the environments that are being created. So as a platform engineer, a platform engineer can start with deployment environments by configuring a dev center and a project, which you might have seen with Microsoft DevBox earlier. It really helps the platform engineers to efficiently and effectively manage their cloud engineering teams and apply similar settings on similar dev teams. And then platform engineers will be able to configure the type of environments a development team can create. It would be based on the stage of development. Earlier, we saw that Jared was able to create a dev or a test environment, and you'll be able to configure an environment type in such a way that only a CI/CD pipeline or a GitOps flow can create a specific environment type, and there are associated settings with it. Similarly, platform engineers will be able to provide this infrastructure as code templates such as ARM or Terraform, and developers will be able to consume them to just create environments out of them. Let's take a look at those capabilities more deeply. So platform engineers are able to define the different types of environments a specific project team can create. For a specific environment type, they're able to control who can create which type of an environment. For example, a development team can be allowed to create only a dev or a test type of an environment. A QA team might be allowed to create all the testing-related type of environments. And finally, a CI/CD pipeline can be configured to create a production or a staging or a pre-prod environment. Per environment type, per development team, they're able to configure a few essential elements. Earlier, when you saw Jared creating an environment, Jared was able to create an environment by providing some basic information, and he was not asked to provide a subscription or a resource group or any of the Azure governance-related aspects. The reason for that is Azure deployment environments provides the ability for platform engineers to pre-configure them. Platform engineers will be able to define what is the subscription in which the resources automatically get created in. This will automatically enforce all the policies that are configured per landing zone or a management group or a subscription on the specific environment type. And the developers need not provide that information. Platform engineers can also configure what are the identities that will be used to create the environment. So whenever a developer selects to create an environment, the service is actually using managed identities to perform deployment on behalf of the user. This is more secure and isolated because these managed identities are specific for this environment type and for this development team. Finally, a platform engineer can also configure what are the different set of permissions that are assigned to the developers when it's created. A platform engineer can assign what is the level of access the creator of the environment would get, and the platform engineer can also configure what is the access level the rest of the team gets. So this really helps developer to stay in their flow, get an environment quickly, deploy their app code, and test their applications. Finally, we also have tags. These tags automatically get applied on all the resources that are being created by the developers. So that way, you can continue to use other tools that you might be using to track and manage costs or the resources in Azure. Azure deployment environments also helps platform engineers to effectively and efficiently manage costs. So we look at cost management in two different aspects. One is cost visibility, and the second one is cost control. First, about cost visibility. Azure deployment environments will help platform engineers track and audit all the environments that are being created by the developers in the Azure portal in one central view. Second, we are looking into cost control capabilities as well, where you'll be able, platform engineers can configure an auto expiry based on the type of environment, such as they can configure that a dev environment can live for 30 days, whereas a sandbox environment just lives for 7 days. So the service will automatically take care of deletion of these environments, so that there are not a lot of Azure resources that are lying around and burning the budgets for the organization. We are also looking into adding a scheduled snooze functionality, especially during the nights or over the weekends when no one is using the dev or test environments. We'll be able to perform automatic scaled down operations to save costs. Now let's move on to the next capability that deployment environments provides. Infrastructure as code templates. We talked about Azure Resource Manager templates and the new support for Terraform infrastructure as code templates that we have announced yesterday. These templates can be provided directly from a source control repo. That is, as a platform engineer, I'll be able to directly attach my code repo as a catalog in the service, and the service will automatically scan through that repository, identify these infra as code templates, and makes them available for the developers to use. This not only helps me iterate through those templates easily and provide latest versions at all the time, it also encourages inner sourcing of these templates among the development teams. Let me now hand it back to Jared to show us the experience the platform engineering team has when they're interacting with the product.
Perfect. Thanks, Sagar. So I'd like to show a little demo here of the experience our platform engineers are going to have in the Azure portal. So I'm going to switch roles. I'm going to take on the role of a platform engineer instead of a developer. So in the Azure portal, platform engineers have access to Azure deployment environments. So now we can see that dev centers and projects are surfaced for our platform engineers. And really, dev centers are a top-level resource that allows you to maintain and control access and security for all projects within your organization. So if we take a look inside our dev center at one of our key features, catalogs. So Sagar had talked about this earlier. Catalogs are a way to inner source infrastructure templates. So what we want to encourage here is the platform engineering team we're giving access to our developers and ensuring that they can make use of these templates and easily spin up environments in a self-serve capacity. So you can actually see in this case here, the repository that we're connecting to our dev center is the same repository that we actually deployed code from a moment ago. So if you wanted, you could change the infrastructure and ship a new feature on that infrastructure at the same time. Let's take a look at our podcast project. Each development team can be thought of as a project. Within each project, we have access to multiple different environment types. And you can see here, these roughly map to our software development lifecycle. So earlier, I was deploying environments in the dev environment type. And when I merged the pull request in, that went to our production environment type, updating the site that our customers actually use. So if we take a look inside our dev environment type, we can configure access to different subscriptions. Now, when an environment is actually created, this is the pre-configuration that allows us to hide some of the complexity for our developers. And that's really what makes platform engineering attractive. When we deploy an environment, it deploys to this subscription. And each environment type has separate deployment subscriptions. Similarly, we can see we configure a deployment identity. So when an environment is being created for a developer, this identity is the one performing that deployment. And we like to keep them completely isolated between environment types. So in this way, we ensure that your dev environment type is never going to have any roles assigned to any production resources at all. There's total isolation between those two. Next up, you can see we have access levels that environment creators get when they create that environment. Some organizations are going to want to grant access to the backing resource group. Others are going to want to restrict that. So ultimately, we want to give platform engineers like me the ability to configure this for our developers. And lastly, we have access to tags. So tags are a feature that we take tags from multiple different levels, so you can configure them on the dev center, the project, or the environment type, and we bubble them down onto the environment. So this helps aid in cost control because you can slice and dice that data based upon the tags that are being bubbled down onto the environment. OK, so we've shown before we can make it really easy to spin up new environments. But we also want to show that for platform engineers like me, I can actually stay on top of the costs associated with all these different environments. So we have our production environment. We have a bunch of CI branch environments. We have some pull request environments. Ultimately, there's quite a few, but we can stay on top of it because we have this view. And more importantly, we can stay on top of the costs. So we have a deep integration with Azure Cost Management. What this does is it surfaces cost information for each environment. So platform engineers can dig deep into what the expected costs are for each environment. In this case, this is actually the production resource group's costs. So you can see roughly it'll cost about $70 per month. But this is going to let platform engineers stay on top of our billing for our developers. And with that, I'm going to pass it back to Sagar.
Thank you, Jared. We have seen how platform engineers are able to efficiently and effectively manage their cloud engineering teams using the concept of dev centers and project. One other important component here is this dev center and a project is common to both Microsoft DevBox and Azure deployment environments. So that way, an enterprise who's using both DevBox and deployment environments will be able to take leverage of it and provide one central mechanism with which a developer can get a DevBox where they can write their code and a deployment environment where they can deploy their code. We have also seen the mechanism with which a platform engineer can provide their infrastructure as code templates. It is directly from a repo, and whenever the repo is iterated, the service will identify those changes and automatically make them available for the development teams to use. And the concept of environment types and the pre-configuration takes all the hassle away from the developers, and there is inbuilt governance that is built, that is there, which enforces and ensures that all of the right set of policies and settings are automatically enforced when the environments get created. Finally, with cost management, it again helps platform engineers stay on top of their costs and also ensure that the cloud-related costs are not burning the budgets of their organization. We have covered a lot in today's session. So let's quickly summarize the entire workflow for you. So as platform engineers, the platform engineers will start with the service, create dev centers and projects to manage their cloud engineering teams. And then they would go ahead and configure the catalog using where the infrastructure as code templates are provided. So as of today, we support ARM, and we'll be supporting Terraform very soon. You can sign up for that early access. And then platform engineers will be able to configure the different types of environments the specific project teams can create. Different project teams can be configured in such a way that they can use different types of environments, and all of the mappings, such as subscription identities, can be pre-configured. Finally, with that, the platform engineers can grant access to the developers to the respective projects. We have two inbuilt roles, a project admin role that can be assigned to a dev manager, and a deployment environments user role that can be granted to a developer, which will enable the developers to directly go out to the dev portal or their favorite dev tool or a CLI and create an environment on their own. They'll be able to create sandbox or on-demand environments from Dev Portal, or as we have seen, they'll be able to directly get an environment when they need through the automation with the GitOps flow. You might have seen that we showed the demo only in GitHub, but you'll be able to achieve this integration with any of the GitOps Git providers that you have. Whichever is the CI/CD pipeline, CI/CD that you're using, you'll be able to integrate with deployment environments and provide the same capabilities, same automated capabilities for your development teams. We're also excited to announce that we are taking it to the next level. You might have heard about Azure Developer CLI in the keynotes earlier today. Even Azure Developer CLI is generally available as of today, and we are working on a close integration between the Azure Developer CLI and Azure deployment environment, so that developers will have a consistent, seamless experience, and they'll be able to continue to use Azure Developer CLI to even create an Azure deployment environment in an enterprise scenario and deploy an application directly onto the provisioned infrastructure as well. So this is something that we have already started working on, when we'll be making it available very soon. Finally, our vision is to empower developers to get an entire engineering system within minutes. We have already embarked on that journey with Microsoft DevBox and deployment environments. We announced both of these services last build, and today we are announcing the general availability of Azure deployment environments. The close integration between DevBox and deployment environments allows developers to get a machine where they can write their code, and a deployment environment where they will be able to deploy their code, identify and fix issues, and then move it to the higher stage environments. And as you have seen, there are many common components between both the services. We have the Dev Center, and the project that you have seen is common for both the services, and the developer will be able to use the same developer portal to create and manage their dev boxes and deployment environments. To recap, Azure deployment environments is generally available as of today. You'll be able to get started with the service for free, and there is no additional charge to use the service. You'll just be paying for the resources that are created as part of the environments. We encourage you to start a POC using Azure deployment environments. Many organizations have already started, and they are leveraging deployment environments to improve the developer productivity in their organizations, and we would love you to do the same. We have also announced Terraform support. So until today, we have been supporting Azure Resource Manager templates. You'll be able to sign up for early access of Terraform, and over the next few weeks, we'll be onboarding you to the service. We'll be able to onboard you to the service and help you experiment with the early access of Terraform support. We also have customer requests to support more infrastructure as code frameworks such as Pulumi or Ansible, and that is something that we'll be working on after we make the Terraform support generally available. So we would be very happy to take any questions in a bit, but we also have a discussion session in 30 minutes in room 335. We'll talk about how we embarked on our journey of deployment environments and Microsoft DevBox. We'll also be sharing the customer experience of the customers who are using the products, and in which scenarios are they using it, what are the benefits that they're seeing out of the service. And finally, we'll be more than happy to answer any questions, and we can help you get started with these services as well. We hope to see you there for sure. And if in case you have missed the breakout session on Microsoft DevBox, it's available on demand, and you'll be able to use the akka.ms here, akka.ms link here to access the on-demand session and watch it. With that, I would like to see if there are any questions. I see one question that popped up here. When should you use Azure deployment environments over Azure Blueprints? How are they similar or different, and what is the appropriate use case for each? That's a great question. So we see Azure Blueprints or Azure Resource Manager templates or Terraform templates or template specs for that matter are different mechanisms with which an infrastructure as code template can be configured. Azure deployment environments is helping enterprises to automate this entire identity management and take care of the actual deployment of the environment as well. As you were able to see, a developer will be able to just pick the infrastructure as code template and then instantiate it to create an environment. As I already talked about, we are also working on integrating with developer CLI, where we'll also help deploy the application onto the provisioned infrastructure. So it's an end-to-end scenario, and the developer can just focus on writing the code that they love to write. So Azure, in short, in a nutshell, Blueprints is also something that we might look at to add as a provisioning mechanism for the infrastructure as code templates that we support. I see there's another question. Do dev environments also support CLI scripts or more complex scenarios, or is it just infrastructure as code via Bicep and Terraform? If I understood the question correctly, the scripts is something, if the question is about Ansible scripts or any other scripts that are typically used, like PowerShell, which are used to provision infrastructure today, that is certainly on the roadmap to expand support to additional infrastructure as code frameworks. Today, with CLI, the CLI can be used to directly create an environment from your favorite IDE's command prompt, or you can go to Azure CLI to create an environment manually, or you can use Azure CLI's custom extensions to automate this entire flow in the GitOps flows that you have.
And just to add one more thing, Terraform does actually have a provider that lets you run scripts. And we should be able to support all providers when we release Terraform support. So that'd be another way to run scripts.
Yeah, Terraform will help support and extends the usage of scripts as well. Any other questions? Sure, please go ahead.
Support Bicep?
Sorry.
Bicep?
So that's a good question. So Bicep is something that we support indirectly today. You can configure all of your templates using Bicep, and there is a very simple tool using which you can convert into ARM and convert into ARM templates and then provision using the catalog. In fact, we have a sample catalog that we have published to help you get started with the service quickly, and all of the templates that have been in the sample repository that we have are built using Bicep, and then we have converted it into ARM. We, in fact, have the tool to convert Bicep into ARM in that repository as well. Please go ahead.
Do you support M365 integrated dev environments, where if you're developing apps for like Teams or even this new Copilot stuff?
That's another great question. So, today we are supporting the creation of any resource that can be created using Azure Resource Manager templates. That is everything in Azure today. But having said that, if you remember 3 slides back, I spoke about our vision. We want to empower developers to get an entire engineering system within minutes. And the Teams-related apps or the M365-related apps, in fact, any of the tools that they might use are also something that we include in the engineering system, and that is something that we are looking into adding and providing a comprehensive end-to-end experience for the developers.
Okay, so not today.
Yeah. Please go ahead.
Yeah, I was just curious if Terragun support is going to be on the roadmap, or is that also integration with is that also coming with Terraform support, or is that coming down the line?
Just to make sure I understood correctly, are you asking about TerraGrunt?
Yeah.
Okay.
Whether it's coming.
TerraGrunt is another popular framework that we get a lot of requests on. Terraform is a long pole for us. So there was a lot of work that we had to put in to support Terraform. Once we support Terraform, once we launch the support for Terraform, supporting additional frameworks wouldn't be such a long pole for us, and we'll be able to support those frameworks very quickly. So Pulumi, Ansible, TerraGrunt is another popular framework that we have requests on, and that we plan to support for sure on the roadmap. Please.
What happens when the code reports you for the environment, but then the capital changes? Is there like an in-place upgrade, or do you need to migrate the environments? What's the life cycle?
That's a great question. So the question is about, we are providing the ability to attach a repository as a catalog. What happens if the platform engineer goes into the repository and changes the template? So if you, we didn't go through it in detail, but we have a capability where you'll be able to perform a sync operation after the changes are made. Once you perform the sync operation in the service, only then we'll pick up the latest templates. Having said that, we have on the immediate roadmap, we have the capability to support versioning and publishing of those templates, and that will help you to provide different versions of the template and track and manage which environment is using which version of the template and move from there. Can I take the additional question? Do you mind repeating that?
What about migration across versions? So if you provide that versioning,
Yeah. During the versioning, in the versioning and the publishing capability that we are working on, we are looking into intelligently analyzing if the change actually breaks an environment or not. And then you will be able to also publish that as a minor version or a major version. So that way, the developers know that whether they can directly consume the change, or if they need to make some change in their application before they can consume the latest version of the template. All right, thank you so much for joining us today. Again, as I said, if you have more questions, please do join us in the room. 335 is the room where we'll have a discussion on both DevBox and deployment environments. Hope to see you again in 30 minutes, and happy rest of the build 2023.